हेलो एवरीवन। आज जो है वीडियो हम बना रहे हैं प्रोफेसर सर्गी के साथ। प्रोफेसर सर्गी जो है यहाँ पे क्वांटम फिजिक्स का डिपार्टमेंट देख रहे हैं मिसिस यूनिवर्सिटी के अंदर। और आज हम इनके साथ कुछ सवाल करेंगे जो कि हेल्प करेंगे नए स्टूडेंट्स को यहाँ पे आने में और उनको डिसीजन करने में कि मिसिस यूनिवर्सिटी के अंदर अगर कोई क्वांटम फिजिक्स के अंदर एडमिशन लेना चाह रहा है तो यहाँ पे उनके लिए क्या अपॉर्चुनिटीज हैं, मतलब क्या चीज़ कंसिडर करना चाहिए एडमिशन लेने से पहले पहले। तो स्टार्ट करते हैं प्रोफेसर से। सबसे पहले प्रोफेसर का इंट्रोडक्शन लेते हैं, उसके बाद फिर इस डिपार्टमेंट का इंट्रोडक्शन, फिर कुछ सवाल जो फ्रिक्वेंटली आप क्वेश्चन है हम उनके ऊपर जाएंगे हम।
Okay.
तो प्रोफेसर अपने आप को इंट्रोड्यूस करवाएंगे, उसके बाद फिर हम प्रोग्राम के इंट्रोडक्शन की तरफ जाएंगे।
Yes, thank you. I am Sergey Mukhim. I am professor of physics, theoretical physics, and I'm chairing department of theoretical physics and quantum technologies at MISIS. Um, Actually, all my life is devoted to research in quantum properties of matter, of condensed matter, and I'm also doing some teaching in this field.
Professor, can you please explain us like about this department, like quantum physics department, like what's going on in this department
Okay.
in the university?
Okay,
Yes.
thank you. Our department was initially called just Theoretical Physics Department. It was organized in 1962, so it's now 62 years old. Uh, but on the other hand, it is very young. I explain in a moment. So in 1962, professor of this university, Professor Boris Finkelstein, got idea that in order to uh, make research and in order to study and find new technologies in material science, it was necessary to go down to elementary particles like protons, neutrons, and electrons, and atomic nuclei. And these substances obey laws of quantum mechanics. And so his idea was to organize special new department for students and for research of the properties of materials, of material science on the level of quantum theory. And this is how he organized theoretical physics department. This was first department, theoretical physics department in the Soviet Union in the technical universities. So this is his big achievement. After that, several chairmen were chairing our department, and also my teacher, Nobel Prize winner, Professor Alex Abrikosov, was chairing this department for 15 years, since 1975 to 1990. Uh, and he brought new flow of ideas, namely because he got Nobel Prize for description of the superconductivity in the superconductors of second type, abricosal vortex. That was his discovery, theoretical discovery. So he brought superconductivity into this university, MISIS, and he brought with him his co-worker, Professor Lev Aslamazov, from Landau Institute for Theoretical Physics, because Abrikosov was one of the founders of Theoretical Physics, Institute of Theoretical Physics of Russian Academy of Sciences. And so this is how superconductivity started in MISIS. After that, there was another head of the department, Professor Vikilov, who introduced one more interesting piece to the life of department and this institute. He introduced computer simulations of solids, of solid state properties, so-called first principle calculations. And now we have supercomputer in MISIS, which is likely 100 teraflops has productivity. And that was next flow of the changes in our department. Finally, when I had become head of this department, um, my contribution, as far as I see it, was the following: that because I have graduated from Moscow Physical Engineering Institute, FISTECH, um, this institute is organized by Peter Kapitsa and his co-workers and friends, and the idea is that professors in our department are also researchers from different institutions of Russian Academy of Sciences, and in this way they brought uh, front edge of their research here to our department, and when they're teaching students they also supervise their diploma work and their research work, and in this sense, in this way we have a permanent connection with the uh, new developments in science, in physics. So, and other thing was that under Abrikosov's being chairman, he uh, promoted opening of experimental laboratory related with the theoretical physics department, and that experimental laboratory um, was doing research in the area of new superconductors and also new multi-ferroic materials. And since discovery of high temperature superconductivity by Bednorz and Müller in 1986, in our department, our experimentalists were able to grow monocrystals of very high quality that were then distributed all over the world, also in the United States, to investigate properties of high temperature superconductors based on cuprate. And so therefore we changed the name of our department, and from theoretical physics it became Department for Theoretical Physics and Quantum Technologies. And now I'm glad that we changed this title of the department, because now we have new quantum revolution, and artificial intelligence and quantum computing is now the aim of our uh, friendly laboratories around our department. And so now these quantum technologies have much sense in the way that they also include qubits, superconducting qubits for quantum computer that are also developed here.
Thank you very much for explaining the great journey from start to till now of this department. Yeah, I hope this will help to understand new students about this department and everything. Now I have some questions about the like about to consider this department and to get an admission into this department in perspective of students, like what they consider in their mind to when they try to select any department or any program to get admission. So I hope uh, this question will be addressed. Like the first question is how deeply do students engage in the quantum mechanics theory in this program?
Yes, thank you for this question. Actually, as I already told in my introduction, quantum mechanics is very important for our times, because quantum computing um, is using the effects of quantum, because quantum computing is directly using quantum mechanics, because the qubit, it is actually a quantum system that could be in the combination of two states simultaneously, and that property is widely used to construct and to operate quantum simulators, quantum computers, and quantum internet. And therefore, quantum theory is very important for um, studying in our department and also for studying our master program, which is called Quantum Physics for Advanced Materials Engineering.
Clear. So the next question is about what practical applications of chemical physics are covered in relation to material engineering.
Yes, thank you. So, as I already mentioned, one of the applications of the program that we conduct is construction of useful parts, useful elements for future quantum computer. Also, our professors are involved in research related with quantum sensors. So these are sensors that could register, say, single photon coming from the depths of universe, and also they are using the superconductivity, which is macroscopic quantum phenomenon, to build up such sensors, which are called bolometers, that have very high sensitivity and can distinguish very low intensity signal, say like 1 or 2 photons, uh, despite the quantum noise on the level of quantum, above the level of quantum noise. So it is very high precision meters. Now, there are other directions in our department related with semiconductors, and our professor, one of our professors, developed very nice new idea how to change usual materials for solar batteries, for example, in such a way that they would absorb and transform sunlight energy into electricity from a very wide spectrum of light frequencies, not single frequency as it was before, but wide spectrum, and this work even in terahertz region of frequencies. And so this work is also conducted by one of our professors. We have also other um, interdisciplinary topics in our department related with lipid membranes and virus interaction with cells of our body. So this is biophysics. We have also a professor who is working in biophysical institute here in Moscow.
Thank you. So the next question is what kind of research opportunities for international students in this field, like if there is any research opportunity for the international students, especially, like is it available? Is there any kind of research opportunity?
Yes. So our program actually is aimed to ignite intuition and curiosity, scientific curiosity in the area of physics in our students. And there are certainly research opportunities. I just to, to, to take it short, one of our previous students who graduated from our master program, he is from India. He then became PhD student also here at MISIS. Then he defended his PhD thesis, and now he is working in theoretical physics department in Russian Nuclear Institute in Dubna. So there is one more our graduate of our department from Cuba. He also graduated successfully from our master program, and now he is PhD student in the area of graphenes. Graphenes that recently got Nobel Prize for the researchers who invented graphenes. So in that sense, we stimulate students to do research. Our professors, because they are working in the Russian Academy of Sciences institutions, they conduct, they guide our di diploma work of our students in the most front edge areas of science.
Thank you very much. So the next question is about are there interdisciplinary collaboration with other fields like, for example, if you talk about electronics, if you talk about nanotechnology, that these kind of fields. Is there collaboration with this?
Yes, certainly yes. As I already mentioned, because we have two professors who are involved in quantum sensorics, so they are doing quantum sensors, and they use for this superconducting devices in the quantum electronic networks. So it's electronics with quantum laws of functioning of these devices, and they're based on quantum effects. So in that sense, our program and research of our professors and diploma students is directly connected to electronics, quantum electronics. Also, we have professor who is working in the Russian Institute for Biophysics, and he is doing research for properties of lipid membranes from which we are built, and this is important research, interdisciplinary, because it proves to be that viruses and lipid membranes, they also obey on the atomic level uh, very interesting laws of nature of physics, and so this is interdisciplinary research in biology and physics, which is biophysics.
Thank you very much. The last question is about maybe you already answered, but I just want to focus on the master program. Like how this program, like master program, address the future of quantum engineering in like quantum technologies and engineering.
Yes, thank you. So quantum technologies and engineering, as we see it now, it is very fast developing area of human activities, and there is even one more interesting phenomenon which we noticed just recently, that quantum mechanics in artificial intelligence, which is called quantum informatics, this is new, very fast developing area. So we, in that sense, we have technologies related with the material science. We have a laboratory that makes research of material properties and prediction of new materials, so that it takes much less time to predict numerically properties of some not existing material, so that experimentalists may synthesize and use it, rather than if the experimentalists would try many samples, which is expensive and much longer time to find new interesting material. So this is material which have special conducting properties, thermoelectric properties, multiferroic, used for all kind of magnetic switches. These are, as I said, superconducting bolometers and sensors that are already flying on few satellites made by our professor, actually, that investigate the history of our universe by sensing photons coming from very far regions of universe. So these are all areas which are involved in our master program.
Thank you very much. I think this answer that you answer will help a lot to the new students who are really making decision to come to this program like quantum physics in engineering. And there is a general question about like if any student want to get like is trying to get admission or is deciding to get admission in PhD and he's interested in, for example. So because maybe the PhD research is going on in Russian language.
Not not necessarily. Um, okay, for example, as I can say about that our graduate who now working in Dubna, he was from India. He actually learned Russian while sitting on the bench outside of my office waiting. So, but in principle, other students who are now in the PhD program, uh, they can have conversations and at least in what is related to making their PhD research and thesis, all our professors are English speaking because they're international level researchers. But I cannot say that all courses are for PhD students are in English, but in principle, mostly our PhD research is concentrated on the experiments and new theories made by students in collaboration with their supervisors, and this is no problem to conduct this in English as well.
Yeah, so this question is very important in their head, like we're sitting outside Russia and they are planning to do a PhD, and they thought that this like PhD should be like will be in the Russian language, so they will really now understand. Okay, it's not in almost 100% not in Russian language. Like they can communicate, they can do research and everything in English because most of the professor here can speak English because they are international professors.
Yes.
Yeah, so this will help them to make this decision in a better way. So anything else if you want to conclude this with the program or any message to the students who are going to join MISIS in quantum physics, you can.
Okay, thank you.
Yeah.
Well, to conclude, I would say uh, what is written on some big universities in the world, in curiosity we trust, and that's our major slogan, and this is what we are for here.
Thank you very much. Uh, Thank you very much for your time and everything, the information you provided us. Thank you. Thank you.
Thank you very much.